There, we got Bridget. Oh, we can't get your face, but alright.
Oh, okay. So this is the residual project that I did. My data took the correlation between the year and the average age of men and women when they got married. I took both separate data, so I have data for when men got married and how old they were for the year, and for women. Uh, there's a positive correlation for both, but just because there's a correlation doesn't mean it's causation. So it's more likely that not ethics, but like morals changed in women, or men wanted to focus more on their career before they actually went into different types of, before they started having a relationship and getting married and stuff. So all the data. The y-axis, or the explanatory variable, is the number of years away from 1990s. I did this because it was just easier for graphing. The x-axis is the age, which is the response variable. For both of them, the residuals are really, really good. There's not a lot of error, but there's a slight sine or cosine type pattern to it, which kind of leads me to believe that if I use sine or cosine as the residual line or the regression line, it would be more accurate, even though both of them were pretty accurate. And then there's some explanatory variables that it could have been, instead of just the number of years or the year it is, would be like the number of people in college compared to when the age of, or the average age of first-time parents, and the number of people in graduate school. Because if one goes up, one of these goes up, the age of the marriage would probably go up. So for the male data, the R-squared is 0.807. That means there is a strong and positive correlation between the year and the age. Because it's so strong and it's positive, because it's strong, the predictions that I've made are most likely to be accurate, in the sense that there's not a lot of, so long as it's with that data, it's not going to be completely random, and there's you can tell where there's an outlier. And then the linear regression line was y equals you see that. So all the ages were between 26.1 and 28.2 with no outliers. They were all within the 20 years. They were all between those two ages. The slope of the average age of marriage over time has increased for men and for women, but it'll definitely continue to increase, most likely because of people wanting to focus on their careers. And then the y-intercept was 26.1, so men just got married probably after they started careers and they could afford to get married and have a family. So women, the R-squared is 0.958, which is an extremely, extremely strong correlation, and it's also positive again. And so the predictions are most likely going to be extremely accurate, and it's going to show that if it's an outlier, it's going to be very, very obvious. So the slope shows the same kind of as the men, where it's it goes up. The age is getting old. People are getting older when they get married as time goes on. And the y-intercept was 23.9. So when they first started, there wasn't a lot of time for them to go to college or stuff like that. So they were probably kind of working again, or trying to get jobs to afford what they could, or who knows. So the predicted values were, because in my data I did there was 17 data points from 1990 to 2010, but the year 1991, 92, and 2004 did not have data points, so I used those ones to make predicted values, and those are my predicted values. In conclusion, kind of on average, women have a lower age of marriage, but they have a higher slope, so it's kind of been their age has increased more quickly than men have. So over time, so there'll probably become a point where they're both about the same when they get married, and that's it.